This presentation will be about building a scalable and flexible MySQL HA environment with Ansible MHA and ProxySQL. ProxySQL in the new player. We like it really much and see how it works with other tools. About me, my name is Miklos Munkaszél. I'm from Hungary and I have a pretty long history with Linux and MySQL. I used to be a backend developer, then as an ops guy. I worked for Walt Disney, and after that I joined to PalominoDB as I was a consultant for many pretty big companies, and I'm a freelance consultant since working for Edmodo. Here you can find my contact in case you have questions. So I built this thing called DAMP. That's a dumb naming, but still. So keep in mind, this is a testing environment. So this is not the use case for Docker, but I wanted to be as portable as it could be, and I didn't want to install anything on the testing computer. So you only need Docker to run and GNU Bash, nothing more. So it's built on Docker, Ansible, MHA, and ProxySQL is licensed in GPL 3. And the important part is the Ansible playbook is eventually an excerpt from a production where we use it with MHA. So this is an enterprise-grade code you have here. You can take it and implement it on your own environment, and you can forget about the Docker, of course. OK, let's move forward. So yeah, as I already mentioned, I chose Docker because I've been using it for a while to testing the Ansible playbooks, and because it's portable. Ansible is my favorite choice when it comes to config management, and it's simple agentless. It's just SSH in and execute the command is necessary. If the change is already there, it won't touch the server. It has templating, a pretty good one, and what is important from our standpoint, that it has modules for MySQL and ProxySQL. Thanks for Ben Weldon for that latter. MH is an old but proven and stable open source HA utility written in Perl. It's easy to configure. It supports automated, non-interactive and interactive master failover, but it doesn't deal with moving with VIPs or any other aspect of the failover. It only deals with changing the topology to the desired. And ProxySQL, thanks for Colin for the great presentation. It's a query routing, rewriting, killing tool based on rules and patterns. It's also a load balancer. You can split reads and writes. It can be used as a query cache. Supports connection pooling. You can prioritize the queries based on the importance, and it supports many more things. But what it is not, it doesn't execute replication topology changes, what MHA does. So they eventually a really good pair because of this. So this is how ProxySQL looks like in a nutshell. This is the application server. ProxySQL has a configuration interface can be accessed via a standard MySQL client, and it stores the configuration items in tables. You can, by default, you can just log in the interface on the port 6032, and the default port for the application is 6033. And based on the routing and other settings, it will route your queries to the desired cluster. Instead of using master and slave, it uses concepts of host groups. So, for example, the master down there is the host group 3, and the host groups 4 are the slaves. And once the topology changes, it automatically detects the changes based on the read-only flag and move the servers from one host group to the other one. I'm going to show this how that works soon. So this is what I built. There is a web server, and everything is running on the Docker. This is not the use case for Docker, but it works fine. We have two clusters here, for example, one with 3 slaves, one with 2 slaves, and there is the admin host. And within the admin host, an Ansible is running locally to configure ProxySQL and MHA based on the inventory file generated during the cluster creation. I'm going to show this, not rocket science, but the automation works pretty fine. And the whole point is you can rerun the playbook once you change the topology or add another cluster, and it will regenerate every possible configuration item within ProxySQL and for MHA to do the failovers, do query routing, or rewriting queries. basically, that was the presentation part, and let's see the demo. I'm gonna create a cluster. So can you see the, let me increase it a little bit. Can you see it from the behind? Yes. Okay. How is it now? Thanks. Okay. So let's create a cluster. Okay, it created cluster 1, 2, 3. I mean, created a cluster called Zephod with 3 machines, 1 master and 2 slaves. We wait for the Docker containers and the MySQL inside to be available. Yes, I'm going to use Hitchhiker Guides to the Galaxy references. Okay, now the application is set up. Let's create another cluster called Arthur. This is going to consist from 1 master and 1 slave. And it will, and this little bash script will also set up the replication. So let's see, we have a host file here. See, the standard inventory file, Ansible file, is generated once the second cluster is ready. There is the inventory entries for the cluster Zephod and the Arthur, and we are going to use the host group 1 for Zephod. And oh, sorry, yeah, again. So we are going to use the host group 1 for Zephod and host group 3 for Arthur this time. Okay, let's start running the playbook. So it's gonna use 2 files as the source of truth. One is the inventory file, and the other is the groups, group words per all. And you can change the ports, the IPs it's listening, the default application user, and password, the credentials it will set up on the MySQL, and the privileges for this given MySQL user. You can change the ProxySQL's global variables here, and rerunning the playbook will apply these changes. It should be done in 60, 90 seconds, depend on the speed of the internet connection. I'm running this on remote machines because it install dependencies for MHA. That's the most time consuming part. Once it's ready, I wrote a little script that makes it easier to demonstrate use cases for the ProxySQL and MHA, doing some sysbench. Yeah, installing sysbench is the last part of this playbook. Once it's done, I call this little guy ProxySQL menu, and well, the list of features is pretty long. So let's see the servers configured in the ProxySQL. Everything is done. So we have a fully set up environment that can be used from an application. There are MySQL servers and clusters behind, and ProxySQL is absolutely aware of everything. So if you see, there is the host group 1, that was for Zephod, and the 2 slaves are in the host group 2, which is the host group for readers. Let me show you how this looks like in ProxySQL. So the writer host group for Zephod is 1 is the writer, 2 is the reader host group, and it's 3 and 4 for the author. So it also generated users. Oh, that was it again. Users is selection 3. There are the users are duplicated because there is one for the front end and one for the back end. But the point is, ProxySQL is set up to use the credentials. So the credentials is set up in ProxySQL is based on the host group. So it will be used app1 for host group 1, and app3 for host group 3, and so on. So let's see a failover with MHA. Oh, by the way, every command we execute here, the terminal is pretty big, are printed above the menu points. So if you go to this menu and start playing with this tool, you can have the actual commands, so you can figure the rest out, and you can customize it whenever you want. So 20 is the interactive failover for MySQL. Yes, we want to run this, and we will change the topology from, so using this master, to using the tree as the new master. Yes, we want this, please. Tip, 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 tip. And switching to master was completed successfully. Check the servers, and we will see that the host group 1 is now contain the IP with the 3, and the rest is in the host group 2. So ProxySQL detected the change, and it moved the servers to the proper host group. This is how easy to do a failover with MHA and ProxySQL. You don't have to do anything. It's absolutely transparent from the application's perspective, which is a great thing. OK, now let's see some statistics. Oh, unfortunately, OK. Query digest is empty. Host groups. It's still empty. OK, let's run a benchmark. To run a sysbench, we have to prepare the database. I'm going to run the sysbench prepare, which is basically this command. It's going to fill the sbtest1 table. Once it's done, we can run let's run a short sysbench read-only test. It's menu.16. Try started. No errors. TPS is pretty OK. So now we are going to generate some traffic to show you. So I can show you the statistics. It looks better if you decrease the size of your terminal. So you can see that every reads and writes went to the host group 1 because that's the writer host group, and by default every application, the app1 is routed to use the master on the host group 1. You can have statistics by the host group, so the summary the sum time spent on the given host group and the number of queries ran there. Now let's change the game a little. Let's run the split read write, which is basically a simple command running replace into. You can see that we are going to add the rule, which is active, that every select should go to the second host group. I mean, this rejects that queries that matches that this rejects will go to the second host group. If you pull the query rules table, this is what is inside the runtime configuration of the ProxySQL now. If we rerun this test and check the statistics, we will see that a lot of queries were being rerouted to the host group 2. Yeah, it's a little bit long for this presentation, but yeah, it's done. So you can see that these lines, these servers with the host group 2 also received reads. You can check the statistics about the host groups. Let's see it over here as well. And there is also statistics about the query digest. So you can see these selects were run on the host group 1 during the previous run, but later on, all the selects were executed on the second host group. So this is how easy to set up ProxySQL to set up a really basic read-write script. Split. OK. How much time do I have? 5 minutes. That's nice. Oh, even better. So let's have two consoles here. And we are going to execute, we are going to see what happens if we are using ProxySQL for reading and doing a failover in the meanwhile. So in one of the windows, I'm going to execute a longer sysbench that's 60 seconds long. And in the other window, I'm gonna execute a non-interactive failover. Eventually, it just doesn't stop you to confirm that you wanna change your topology. No worries. Okay, so we switched the master successfully in this window, and the other window, there is this part when the failover happened, right under, way under 1 second, by the way, not around 1 second. There were some reconnects, but ProxySQL can resend the select queries if the underlying database dies. So it's really cool. Basically, this is what happens when you experience a failover during reading through ProxySQL. And, well, I also added some minor things like create a Word database. Since we have some minutes, let me show you how to add another cluster to this setup. Damp. Let's stick to this example. Let's add the cluster with 2 machines called Trillion. And it's done. Let's check the host file. Here you can see there is a third cluster appeared with the host group 5, so the users will be F5, while on the MySQL server, the credentials on every MySQL server is up and Gampa, which is configured here. So don't mix the two. These are the credentials on the MySQL servers, and ProxySQL makes it transparent, and you can use different kind of credentials there. Just saying. Okay, now we have this new inventory file. We can just read on the playbook, which is basically this command. You should wait like 60 seconds. We don't have to reinstall everything. So if the ProxySQL is already installed, Ansible won't install it again, and it won't execute most of the part. Only the part when it says changed. Adding new servers, that's something we want to add. We want to change with Ansible. Yeah, we are now generating the config file. That's it. And if you check the here ProxySQL menu, and the second is the show servers. The server Trillion appeared. Its user appeared. It's in the it has its own host group, and well, yeah, that doesn't change at all. And for example, there is also a log part of this little script that can show you the most important log files, the read-only, the ping, and the connect log. And here you can see how it maps the servers in order to move it to the proper host group. Basically, this is what I wanted to show you. Questions?
You have time for questions. So when you first created those three hosts, right, like master states, you had in the servers table of SQL, you had one entry for master on one host group, and second host group had 2 slaves. Right? Then you went from the failover. You can see that master is included also in this video.
Yes.
So could you just why happened?
ProxySQL also adds the writer to the readers by default, because master is a source of read, and you can wait. You can also set up waits for the server. So if the master outweighs the slave, then the queries are sent there more likely. This is the expected behavior when you want your data back immediately, and there is no chance of having replication lag. By the way, ProxySQL checks the replication lag, and you can set up a threshold, so it won't send reads for a slave that's higher than a given threshold. Sorry, by the way, Christoph asked, why is the writer in the reader host groups as well? That was the question. So the writer by default is also part. The ProxySQL monitor also puts the writer instance to the reader host group. Anybody else?
Thank you.
Thank you.